In this video, we will talk about the disjunction operator, or sometimes I'll call this the OR operator. So if I want to express the sentence or the proposition P or Q, this is a proposition called the disjunction. The disjunction of P and Q, and it's denoted P and then this V symbol, Q. So next, I want to write a truth table for P or Q. Okay, so two propositions go into building this one. So I'll write P and then Q. Put those on the left-hand side of these double vertical bars, and then I'll put P or Q on the right-hand side. So on the left-hand side, I do the same thing that I did with conjunction. After I write down all the different truth values for P as well as Q. So for Q, I'm going to alternate true, false, true, false, true, false, true, false. I know there's going to be 4 total rows because there's 2 options for what the truth values of P, 2 options for the truth values of Q, and those multiply to give me 4. And then for P, I'll do 2 trues, 2 falses. And if I had more rows, I would keep alternating 2 trues and 2 falses. So now I got to think about, well, when is P or Q going to be true? And before I do that, I need to say something important about this OR, which is in this OR operator, or this disjunction operator, the word OR is always considered to be an inclusive OR. So that said, for P or Q to be true, either P or Q or both need to be true for P or Q to be true. So that means when I'm filling out this truth table, when both of them are true, as in this top row, P or Q is, not false, it is true. And in the next row, P is true, one of them is true, so that's good enough for the OR statement to be true. Even in the third row, one of them is true, so that makes the whole thing true. And in the last one, neither is true, so there P or Q is going to be false. So in other words, if at least one of P or Q is true, then the OR statement, the OR proposition is going to be true. All right, so I want to note something about exclusive ORs. So there is an operator for an exclusive OR as well, but we won't cover it in our class. So I want to focus on the 3 that we've done so far, as well as something called the conditional operator, which we'll talk about in our next lecture. So in English, we distinguish whether OR statements are inclusive. They are inclusive, or whether they are exclusive from context. So let's do two quick examples. So let's say first I have the sentence that says, I can wake up early or I can sleep in. So if I focus in on this word or here, in this context, could I do both? Could I wake up early as well as sleep in? So no, that wouldn't really make sense. So this is an exclusive OR. I'm doing one of these things, but not both of them. I'm either waking up early or I'm going to sleep in. What about this next sentence, which says people with kids or pets get less sleep? So in this context, people with kids get less sleep, people with pets get less sleep. So intuitively, it makes sense that if you have kids and pets, both of them, you're definitely going to get less sleep. So this is an inclusive OR. So we are determining that from the context of the sentence. All right, so I want to end this video with a memory tip. for how we can remember the symbols for and or. So the symbol for and, remember, is this upside down V. And this is like an intersection, which is an upside down U. It's just made into sharper lines. So remember, this is the symbol for intersection, back when we talked about sets for intersection. And we know that an intersection means the word and. Whereas the symbol for or is just a V shape, and that is like a union. So that was the symbol for union, the U. And the union means, in words, it means or. So that's one way to remember the symbols for and or. There's like the symbols for intersection and union, just with sharper, straighter lines. So in the next video, we are going to practice translating sentences to logical symbols.